let me just tell you the other representation, okay, of set of all feasible allocations. So this is Dolbear's, okay. So again, I'm going to just use this one, and this has a feasible allocation, set of all feasible allocation. I'll represent it in the Dolbear's triangle. So in the Dolbear's triangle, what you do is, again, you'll be drawing a triangle, but you will be drawing a right triangle. Okay, so it's not an equilateral triangle. Okay, it's a right triangle that you'll be drawing. Okay, so this is the origin of 1. Okay, and this is x1, and this is g. So so far everything is exactly the way you have seen in the other situations, when we have private good scenario. Okay, but the only difference here is this, that for individual 2, the vertical axis is not going to be like this. Okay, for the individual 2, it will be like this. Okay, so what you're going to do is you're going to look at what is the total endowment of private good in this economy, which is 10. So it is 10. So you're just going to mark this point 10 here, and from here you're going to draw a 45-degree line. Okay, now why are you drawing 45-degree line? Because your production function is g is equal to fx is equal to x. Okay, so you will be basically drawing your production function here. Okay, that's all that you're doing. Okay. Okay, so now let me tell you exactly, why is this triangle going to give you another representation of set of all feasible allocations. Okay, so so this is 45-degree. Okay, this is 45-degree because, as I've just told you, you're just plotting g equal to fx. Okay, so you can say that in this direction x2 is increasing, as well as x0 is increasing. So what is x0? X0 is the amount of private good that is used as input in the production of public good. Okay, so basically g is equal to fx0. Okay, and you have this feasibility requirement, so you can just write it as x0 plus x1 plus x2 must be equal to 10 in our case. Okay, so that is why you have this length equal to 10. Okay, so now let me just explain how is this going to give you set of all feasible allocations. So if this is 10 and this is a 45-degree line, this must also be 10. Okay, now let us look at a point like this. For example, this height represents the amount of public good that is consumed by both the individuals, individual 1 and individual 2. You can say that this is the origin of individual 2, and this length is the amount of private good consumed by individual 1, and this length is the amount of private good consumed by individual 2. Okay, now you can easily see that this plus this will be exactly 10 no matter what point you pick. So this is an arbitrary point. Okay, so obviously the similar kind of thing you can plot elsewhere as well, and you'll get a t like this. Okay, so I'm just going to show that x1 plus x2 plus g will be 10. Okay, and that will be that's just going to make it clear that we are able to represent the set of all feasible allocations in this kind of triangle. Okay, so why is this 10? Well, that's kind of easy, because if you see, this height is g, so this height must also be g. Okay, and because this is a 45-degree line, so if this is g, then this must also be g, right? So if this is g and this is x2, so this must also be x2, right? And if this is x1, then this must also be x1. So you can see that x1 plus x2 plus g is equal to 10. Okay, so that's basically the reason why you can use this triangle to represent the set of all feasible allocations. You can see that g in this triangle or in this triangle has this property that it's non-rival and non-excludable. Okay, you cannot exclude anyone from consuming the public good. You cannot, like, if g increases, it increases for both. Similarly here, if g increases, it increases for both. Okay, and if you cannot exclude anyone as well, because if you make g 0, then you have to exclude everyone. You cannot exclude just one person. If you make g 0, then g 0 for both. Is that clear to everyone? So it's non-rival, non-excludable. Okay, and that is exactly what both these triangles illustrate. Okay, Well, if the production function is not linear, then let's say, for example, it is root of g, okay, then all that you have to do is you just have to draw something like this. Okay, the root of function, and then it will not be a triangle, it will be a region like this. Okay, and that's going to be the set of all feasible allocations. Okay, and that's the, basically that's why, this particular triangle has its advantage over this one, because you can also represent technologies which exhibit decreasing returns to scale or increasing returns to scale, using this kind of framework. Okay, so let me ask you some questions so that I know that you have understood the set of all feasible allocations. So can you tell me where is this point located? X1, X2, G equal to 5, 5, 0. This is feasible, right? Because X1 plus X2 plus G is equal to 10. Where is this point in this triangle? Very good. Okay, so it's just exactly in the middle of O1 and O2. Very good. Okay, and where is this point located? 0, 0, 10. Very good. Okay, this is exactly where we have this particular allocation. So likewise, if I pick anything in the middle, 2, 2, 6, the height will be 6. Okay, so G will be 6, and then this length will be 4. So you can just take the midpoint of that. That's going to be 2, 2, 6. Is that clear to everyone? Okay. Okay, so basically you can use this to represent the set of all feasible allocations. That's the point. Okay, and then not only that, you can also use it to figure out Pareto efficient allocations. I mean, it's actually a very good way to use graph to figure out set of all Pareto efficient allocations. Okay.